This recording covers Charles' law, and this one is about temperature and volume change for gases. What this one says is that the volume of a fixed mass of gas is directly proportional to its temperature as long as you use Kelvin and if you're keeping your pressure constant. The math equation for this one is that V1 over T1 is going to equal V2 over T2. In terms of what the graph of this looks like, if you have temperature as your independent variable and volume as your dependent variable, you'll get a linear relationship between the two. Now, you're well aware of this. If you think about a balloon at a relatively cold temperature, and let's say this is a 1 liter balloon, and we're at 0 degrees Celsius. If we take this balloon and we put it someplace warm, let's say we bring the temperature up to 50 degrees Celsius, you would see that the volume gets larger. And I've shown here that our volume is now greater than 1 liter. What this law does here is it allows us to calculate how much larger it will be. So let's try this problem here. You buy a helium balloon for your friend's birthday party. It has a volume of 8 liters in the store at 101.3 kPa and 20 degrees C. How large will the balloon be after you leave it sitting in your hot car at 60 degrees C? Pressure is still going to be 101.3 kPa. Well, the first thing we do, because it's an easy opportunity to make a dumb mistake, is we're going to change our temperatures over to Kelvin. Anytime you're working with gases, you need to do that. So we're going to take these two temperatures, and I'm going to make up a new word. We're going to kelvinate them. So we're going to turn them to kelvins. This becomes 293 kelvins. And when we kelvinate this one is going to become 333 Kelvin. Our pressures have remained constant, so we can just ignore our pressures. So what we're interested in is what is happening to the volume. So it has a volume of 8.0 liters. So our V1 is 8.0 liters. Our T1 is 293 K. Our V2, well, that's what we're looking for. And then our T2 is 333 K. So let's just go ahead and write this out. V1 over T1, so we're going to have 8 over 293 equals V2 over, and I left a 3 out there, let's put that in there, over 333. If you've forgotten how to do that, it's cross multiply and divide, so 8 times 33 over 293. Cross multiply and divide. And when you do that, and we use two significant figures based on the 8.0 liters, you get that your new volume is 9.1 liters. So let me rewrite that for you, 9.1 liters. Let's put a box around it to indicate you're done. Now, you're going to take the same balloon to Antarctica, where the balloon's volume shrinks to 6.9 liters. You're still at 101.3 kPa, so we can just ignore that. How cold is Antarctica in degrees Celsius? So we can use the same V1 and T1 because it's the exact same balloon. So V1 equals 8.0 liters. T1 equals 293. Our V2 equals 6.9. And we need to find out what our T2 is in terms of kelvins, and then we're going to convert that to Celsius. So we go ahead and set that up. We're going to have 8.0 divided by 293 equals 6.9. Divide that by, and we need to figure out what our kelvins are there. Our answer ends up being 253 K. We're going to subtract 273 degrees to get minus 20 degrees Celsius as our final answer. At this point, you're ready to try some Charles' Law problems.